Here's a surprising fact. Over 80% of the world's goods travel by sea, and almost all of that movement relies on one kind of product, the shipping container. Without them, global trade as we know it simply wouldn't exist. But how do you mass-produce millions of identical watertight steel boxes that can survive years of salt, storms, and heavy stacking? Today, you'll witness a process that combines heavy steelworking with surgical precision, all happening inside giant factories you've probably never seen. Once you watch this, you'll never look at a shipping container the same way again. Imagine a plain slab of steel being pulled across a factory line and slowly pressed into the ribbed sides of a shipping container. At first glance, those grooves might look like a simple design choice, almost like decoration. But they are there for a very practical reason, and without them, these containers would never survive on ships stacked level after level in the open ocean. It all begins with enormous sheets of weathering steel, the material chosen specifically for its ability to resist the harsh conditions of long ocean voyages. This isn't just any steel. It's engineered to stand up against saltwater, temperature changes, and years of rough handling. Workers or machines feed these sheets into giant rolling presses where the smooth surfaces are shaped into waves. The first step doesn't look very glamorous. A flat plate goes in, a crinkled one comes out. Still, that small change in shape makes an enormous difference in what the container can handle. Why would anyone go through so much trouble to change the texture of steel instead of simply leaving it flat? The answer lies in how steel reacts to stress. A plain sheet, even if it is heavy and solid, will eventually bend when pushed by wind, shifting cargo, or the weight of other containers above it. By adding ridges, like folds pressed into sturdy paper, you create a structure that can handle much more pressure without requiring extra material. Just like how a piece of folded cardboard is harder to crush than the same cardboard left smooth, corrugation adds strength without adding waste. The material itself also helps. Factories use a form of weathering steel often called COR10. Unlike normal steel that begins to corrode as soon as it's exposed to salt, this alloy forms a tough surface layer that locks in the rust and stops it from spreading deeper. That means the walls will last much longer at sea, even in humid, salty air, with far less upkeep required. It's a simple idea, but incredibly effective when multiplied across millions of containers that are expected to work for decades. These corrugated panels don't just appear one at a time. Production lines are set up to run constantly, with machines pressing sheet after sheet, day and night. Each line can turn out wall sections by the thousands. As soon as they're shaped, robotic welders and cutting machines trim and join them, making the process fast and uniform. It's a mix of heavy industry and precision engineering, letting companies keep up with global demand. Watching these panels roll off the machines, it's hard not to wonder how they'll be pieced together into the box shape we all recognize. The real purpose of those grooves becomes clear when you see containers stacked on a cargo ship, sometimes 9 high. Without the reinforced ridges, the steel would crumple under the combined weight. With the walls secured, attention in the factory shifts to the next critical challenge: building a base strong enough to carry that weight every single day, the floor frame. What part of the container actually holds thousands of pounds of cargo day after day? Hint: it's not the corrugated walls you notice first. The real work begins with the base, a floor frame built from long steel I-beams. Arranged in a grid, they form a lattice strong enough to spread weight evenly across the whole box. Without this hidden framework, the wood floor above it would collapse the moment a forklift drove in, or the container was stacked at the dock. At first, this design might seem overbuilt, but remember that a container has to be moved by cranes, hauled onto trucks, and stacked on ships. It needs to be light enough to make transport economical yet engineered to last decades. Forklifts slam heavy pallets onto the floor repeatedly. Saltwater sprays from the ocean cling to every edge. Even in storage yards, containers get knocked, dragged, and sometimes dropped. The base needs to handle all of that punishment without warping or splitting. That's where the choice of flooring material matters. Instead of ordinary lumber, the manufacturers use marine-grade plywood. This isn't the type you'd find at a hardware store for home projects. It's prepared with special glues that resist moisture and bonding methods that stop the layers from peeling apart. The sheets can stand up to wet conditions, resist rot, and protect against invasive pests. Cargo ships carry containers to nearly every corner of the world, so the flooring has to meet strict rules to prevent insects hitching a ride across borders. Each board of plywood doesn't just get laid down loosely. Workers measure and cut each panel before applying chemical treatments for extra protection. Then, one by one, they screw the boards directly into the steel beams below. The spacing of screws may seem like a small detail, but it locks the floor in tight so it won't shift, creak, or break under the vibration of transport. Around the edges, liquid sealants are brushed and set into place, filling the gaps between wood and steel. This keeps moisture from seeping in and slowly destroying the floor in the damp hold of a ship. With the floor frame established, the next step is building and access. The container's giant double doors are made from corrugated steel sheets, surrounded by heavy square tubing. Rubber seals run along the edges to block out water, while locking bars stretch vertically down the face of each door. When the bars rotate into place, the entire panel is pulled tight against the frame, shutting the box completely against wind and rain. The doors wouldn't matter without strong vertical supports. These come from the corner posts, tall hollow steel columns placed at each edge of the frame. They act like load-bearing legs, carrying the weight of stacked containers straight down through the base. It's these posts that allow containers to be piled safely without crushing the boxes below. So why all the fuss over waterproofed plywood and sealants? The truth is, these treatments don't just battle seawater. They also protect against termites and other invasive pests, meeting worldwide shipping regulations. With the walls, floor, and entry secured, the container is almost complete. The final task is to tie it all into a sealed, certified box that can officially join global trade. Before a container ever carries its first load, it has to prove that it can survive years of storms and rough handling. So how do factories make sure every single box will hold up? The answer is the final stage of construction, when all the parts come together into a closed, sealed structure and then face a series of checks before being released into the world. At this point, the side panels, floor frame, doors, and roof sections are positioned and welded into place. Strong weld lines run down every edge, turning the individual components into one solid box. Any weak spot in this stage could lead to cracked joints later, so factories use both robotic welders for precision and skilled workers to inspect and reinforce seams as needed. Once closed up, the container gains its familiar form, but the real test is keeping water and corrosion out for decades. Even the tiniest leak can ruin a shipment. If seawater seeps inside, the cargo may be damaged beyond recovery. A single crack around a door seal can cost thousands in insurance claims. To prevent that, every surface goes through a protective coating process. First, a layer of primer is sprayed on to bond with the steel. Over that, several coats of industrial paint are applied. The outer paint doesn't just add color or branding. It resists salt spray, sunlight, and constant exposure to weather. Each layer serves as a barrier, slowing down or stopping corrosion from ever reaching the steel beneath. Factories pay special attention to the underside, where floors meet the frame. Sealants are spread carefully along every join, corner, and edge. These materials fill in invisible gaps where water might slide in. Once cured, the sealant forms a permanent waterproof layer that's hard to notice but vital to the life of the container. Without it, moisture could creep in and destroy both wood and steel from below. With coatings finished, the containers move down the line for testing. Long rows of freshly built boxes are lined up, and powerful water jets spray across the walls, roof, and doors. The inspection teams look for even the smallest trickle inside. If a single drop gets through, that container fails and must be resealed. Containers that pass can finally be prepared for use. But before they reach shipping lines, another layer of approval is required. What looks like a plain steel box is actually the result of careful planning and global-scale production. Every wall, floor panel, and seal is chosen so the container can safely carry trade goods across oceans, through ports, and onto trucks or trains. These boxes make it possible for 80% of the world's trade to move reliably without breaking down. So the next time you spot a container rolling by on a train or stacked high at a dock, think about the massive unseen process that went into making it. Each one represents modern trade quietly at work.